Hello, math learners! Our lesson for today is about the zeros of polynomial function in factored form. The learning objectives are: you are going to apply the zero product property and basic theorems of algebra. Determine the degree and the zeros of polynomial functions and solve polynomial equations. Let us have important notes. The zeros, or can be spelled out as zeros without e, of polynomial function represented by p of x are the roots of the corresponding polynomial equations represented by p of x is equal to 0. This implies that if p of c is equal to 0, then c is a zero of the polynomial. And the factor theorem states that x minus c is a factor of a polynomial p of x if c is a root or a zero of the polynomial. Let us have first zero product property. The roots, or can be called as zeros, of polynomial can be found by equating each factor to 0. Let us have the fundamental theorem of algebra. Every polynomial function has at least one zero or root which is real or imaginary. And let us have the number of zeros theorem. Every polynomial function of a degree n which is greater than or equal to 1 has exactly n zeros. Let us have examples on how to determine the number of zeros of the polynomial function. Given the polynomial function represented by f of x is equal to 3x raised to the exponent 31 plus x raised to exponent 21 minus 2x raised to 11 plus 7x. f of x is of the 31st degree. Hence, f of x has 31 zeros. Number 2. The polynomial function represented by g of x, given in factored form. So we have the quantity x plus 2 raised to 4 times the quantity 3x minus 1 raised to 2 and the quantity x minus 1 raised to 5. G of x is of the 4th plus 2nd plus 5th degree, which is equivalent to 11th degree. Hence, it has 11 zeros. Take note, in this given polynomial function, in the quantity x plus 2 raised to 4, the linear factor x plus 2 occurs 4 times. Meaning, this can be written in this form. You have the quantity x plus 2 times the quantity x plus 2 times the quantity x plus 2 times the quantity x plus 2. The corresponding zero, negative 2, is said to be of multiplicity 4. So meaning, negative 2 appears 4 times. And to get the value of x, which is negative 2, all you have to do is to equate x plus 2 to 0. And transpose positive 2, there you have negative 2. Next, in the quantity 3x minus 1 raised to 2, the linear factor 3x minus 1 occurs 2 times, or can be written in this form. The corresponding zero, which is 1/3, is said to be multiplicity 2, or can be called as double zero. So you have 1/3 and 1/3. And the solution is 3x minus 1 equals to 0. Transpose -1, you will have 1. Divide both sides by 3, so x is equal to 1/3. And in the quantity x minus 1 raised to 5, the linear factor x minus 5 occurs 5 times. Or this can be written in this form. And the corresponding 0, 1 is said to be of multiplicity 5, wherein 1 appears 5 times. And to get the value of x, which is 1, all you have to do is to apply the zero product property, wherein you have to equate x minus 1 to 0. So solve for x, transpose -1, it is positive 1. Let us have examples on how to determine the degree and the zeros of the polynomial function. Example number 1. The given polynomial function is p of x is equal to the quantity x minus 3 times the quantity x minus 4 times the quantity x plus 7. For the degree, it is 3 because the first binomial factor is in the first degree, the second in the first degree, the third one, it is also in the first degree. Just add 1, 1, and 1, so it is 3. So the degree is 3, or it is in the third degree. The zeros are 3, 4, and -7. For the solutions, you have to equate the binomial factors to 0. All you have to do is to use the zero product property, which means equate each linear factor to 0. The first linear factor is x minus 3. Equate to 0. The second linear factor is x minus 4. Equate this to 0. The third linear factor is x plus 7. Equate this to 0. And then solve for the value of x. Just transpose -3, so you have x is equal to 3. Transpose -4, so x is positive 4. And transpose positive 7, then you will have x is equal to -7. For the second example, given p of x is equal to the quantity x minus 8 times the quantity x plus 9 times the quantity x plus 2. The degree is 3. So again, this is in the first degree, first degree, first degree, a total of 3. And the zeros are 8, -9, and -2. For the solutions, you have to equate the binomial factors into 0, and then we have to use the zero product property, which will mean we have to equate each linear factor to 0. So x minus 8 equals to 0. X plus 9 is equal to 0. X plus 2 is equal to 0. And then solve for the value of x. So x is equal to 8, x is equal to -9, and x is equal to -2. Next example. Given the polynomial function equals to the quantity 2x plus 1 times the quantity 3x minus 5 times the quantity x plus 7. The zeros are -1/2, 5/3, and -7. For the solutions, we have to use the zero product property. So equate each linear factor to 0. So you have 2x plus 1 is equal to 0. 3x minus 5, equate this to 0. X plus 7, equate this to 0. And solve for the value of x. So here, x is equal to -1/2. Just transpose 1, it becomes -1, and divide both sides by 2. Then, here, x is 5/3. Transpose -5, it becomes +5, and divide both sides by 3. And here, x is equal to -7. That is why the zeros are -1/2, 5/3, and -7. Let us have the given polynomial function is represented by f of x. You have the square of x minus 3 times the cube of x plus 1 times the quantity 2x plus 5. The degree is 6. The first one is in the second degree, the second one is in the third degree, and the third binomial factor is in the first degree. Just add 2, 3, and 1, it is 6. It is in the 6th degree, or the degree is 6. For the zeros, we have 3, negative 1, and negative 5 over 2. 3 appears 2 times, or we have a double zero or multiplicity 2. Negative 1 appears 3 times, or multiplicity 3. And negative 5 halves is a single zero. Let us have the solutions. Using the zero product property, we have to equate each linear factor to 0. So, the first is x minus 3, equate this to 0. X plus 1 equate to 0. 2x plus 5 equate to 0. And then you have to solve for x. So, x here is 3, then x here is negative 1, and x here is negative 5 over 2. Number 5. The given polynomial function is represented by g of x, which is equal to x cubed times x plus 2 times the quantity x minus 4 raised to 5. The degree is 9 because the exponent here is 3, here is 1, here is 5. So we have 9, or it is in the 9th degree, or the degree is 9. The zeros are 0, negative 2, and 4. 0 is a triple zero, or multiplicity 3. Negative 2 is a single zero. And 4 is a zero of multiplicity 5, meaning 4 appears 5 times. For the solutions, again, we have to use the zero product property. Equate each linear factor to 0. So we have x is equal to 0, x plus 2 equals 0, x minus 4 equals to 0. And solve for x. The first one, we have already x is equal to 0. Then, x is equal to negative 2, and x is equal to 4. That is why we have 0, negative 2, and 4. And all in all, there are 9 zeros. 3 with a value of 0. There is only 1 with a value of negative 2. And 5 zeros with a value of 4. Next. The given polynomial function is represented by h of x equals to the quantity x squared minus 1 times the quantity x squared plus 4x plus 4. You can simplify the given function into the quantity x plus 1 times the quantity x minus 1. They are the binomial factors of x squared minus 1, which we called as the difference of two squares. And the second factor is a perfect square trinomial, which can be written as the square of x plus 2. And this is called the square of binomial. All we have to do is to apply the special products in finding the factors. The degree is 4 because the exponent here is 1, 1 here, and then 2. So all you have to do is to add. It is in the 4th degree. The zeros are negative 1, 1, and negative 2. And negative 2, a double zero, or multiplicity 2. For the solutions, we have to use the zero product property. So equate each linear factor to 0. Then we have x plus 1, equate this to 0. X minus 1, equate to 0. And x plus 2, equate to 0. Then solve for x. So x is equal to negative 1, x is equal to 1, and x is equal to negative 2. That is why we have negative 1, 1, and negative 2 as a double zero or multiplicity 2, or negative 2 appears twice. Do you have questions? If there is none, let's proceed. Let us have examples on how to solve polynomial equations. Number 1. Given the square of x plus 2 times the quantity x minus 1 raised to 4 is equal to 0. This can be written as the quantity x plus 2 times the quantity x plus 2 times the quantity x minus 1 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 equals to 0. The degree is 6. That's 2 plus 4 is 6. The number of zeros or roots is also 6. For the zeros, we have negative 2 as a double zero and 1 as a zero of multiplicity 4. For the solutions, use the zero product property. So we have to equate each factor to 0 and solve for the value of x. So x plus 2 equate to 0. X is equal to negative 2. The factor x plus 2 is raised to the second power, which implies a double root. X minus 1 is equal to 0. So x is equal to 1. The factor x minus 1 is raised to the fourth power, which implies a root of multiplicity 4. Next, the given of number 2 is x squared times the cube of 2x minus 3 is equal to 0. This can be written as x times x times 2x minus 3 times the quantity 2x minus 3 times the quantity 2x minus 3 equals to 0. This is the expanded form of the given polynomial equation. The degree is 5, so you have 2 plus 3. The number of zeros or roots is also 5. The zeros are 0 as a zero of multiplicity 2 and 3 halves as a zero of multiplicity 3. For the solutions, we have to use again the zero product property, which means we have to equate each linear factor to 0 and solve for the value of x. So the first one, x is equal to 0. So the value is already 0. And the factor x is raised to the second power, which implies a double root or a root of multiplicity 2. For 2x minus 3 is equal to 0, x is equal to 3 over 2. The factor 2x minus 3 is raised to the third power, which implies a triple root or a root of multiplicity 3. That is why the zeros are 0 and 3 over 2. 0 appears twice and 3 over 2 appears thrice. So all in all, there are 5 zeros or roots. Do you have questions? If there is none, then see you next time. Bye!